All right, folks, it's Bass Action, back in action here. In this video, we are going to look at how to graph a cotangent function. Before we get into the actual graphing, we want to also unwrap the unit circle, just like we did for our tangent graph, so that we can understand how the unit circle actually creates this shape for our cotangent function. So let's jump into evaluating, for all of these particular angles, the cotangent function. So cotangent of a negative pi over 2, starting here on the far left, is going to give us a 0. At a negative pi over 4, we'll have a negative 1. At 0, we'll have undefined. Remember, the undefined values are going to be really important for us. Pi over 4 is 1. Pi over 2 is 0. 3 pi over 4 is a negative 1. Pi is going to be undefined. 5 pi over 4 is 1, and 3 pi over 2 is 0. All right, so those undefined values, let's grab those first. Anytime a function is undefined, it's going to create these vertical asymptotes for us. Remember, our functions go forever in both directions, so you can see I've got a period over here beyond what I've shown on my unit circle. The values where cotangent evaluated to 0, those angles are going to be where it nicely crosses our x-axis. And then the values where they equal negative 1 and 1 are going to give us these values right here. So at a negative pi over 4, we have a negative 1. At a pi over 4, we're going to get this 1, then our negative 1, and our 1 and our negative 1. So those are all going to connect back to our unit circle. What's important for us to really notice here is that we have a nice asymptote right here on the y-axis. And this is going to be a much easier one to shift for us than what we had to do for the tangent function. So we're going to focus on moving that asymptote when it comes to doing our phase shifts. So let's take a look at an example and go through those steps, always keeping in mind that what your teacher requires might be a little bit different. So we're going to find our vertical translations in the same way we always do. We're going to look for something to be added or subtracted from the front or the back end. We see that there is nothing added or subtracted there, so there's no vertical translation here. Our vertical stretch, remember, was sine, cosine, cosecant, and then even our cosecant and our secant, because those kind of came from it. We would always think of that as looking for an amplitude. So amplitude is going to be for sine and cosine. All of our other functions, we're really thinking stretch, okay? So sine and cosine have a special language, but we're going to find it in the same place. We're going to look at that leading coefficient, so we can see that we're going to have a vertical stretch of 5. There's no reflection. We would find that in the same place as a negative in front of the function, so there's no reflection here. Our period, the period is going to be very similar to the tangent function, but is different from the sine and the cosine, and that the distance between the asymptotes on the parent function, remember, the distance between our asymptotes is our period, and the distance between the asymptotes on the parent function is pi. So we're going to use pi to determine what our new period will be. This one does have a period change. We're looking for that as the coefficient on the x, so we're just going to divide that by 2. So our period is going to be pi over 2. Now, to find that first asymptote, remember, we're going to ask ourselves, how does this move? And we're talking about that first asymptote. And we're talking about that first asymptote. So we could, if we wanted, we could take this entire expression here. You could separate the period change from the phase shift. We've done that several times already. But this time I want to show you the other way. We're going to say 2x minus 2 pi over 3. And we can set that entire expression equal to 0 because we're trying to move that first asymptote that's at 0. So we're going to do a quick solving for x. So 2x is going to be 2 pi over 3. So our first asymptote we are going to place at pi over 3. Now, our distance between our key values, we're going to take our period, we're going to divide it into 4 pieces. Our period was pi over 2. Of course, that's going to be weird to write as divided by 4, so we're going to think of it as times 1/4. So we're going to space each of the key values out by pi over 8. Now, when we calculate those key values, we're going to take that first asymptote of pi over 3, and we're going to add to that. Remember, we could subtract it as well. That subtraction is going to become important here in a moment. We're going to add to that this pi over 8. Now, we've got to get some common denominators before we can do much work here. So I'm going to multiply this by 8 over 8. And I'm going to multiply this by 3 over 3, which means what I'm thinking in terms of my tick mark values, we're actually going to be thinking of this as a pi over 24. That's going to be kind of weird, but it's going to actually work really nicely for us. We're going to think pi over 24 in terms of each of our little tick mark values, okay? So when I start off at this pi over 3 and I add that pi over 8, that's going to get my next value. We're going to have an 8 pi over 24 plus a 3 pi over 24. And if I do that, this 8 pi over 24 plus 3 pi over 24 is going to get me to an 11 pi over 24. And if I'm thinking of each of these values as pi over 24, I'm thinking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I see that I'm really almost already off of my grid that I have. So I'm actually going to work this problem in the negative direction. So let's go ahead and put this first asymptote on here to help you guys visualize what I'm doing here. So I'm going to count over 8 pi over 24. So 1, 2, 3, let's count these. 1, 2, 3, 4, 5, 6, 7, 8, right here. So I'm going to put this asymptote right here. Since each tick mark represents a pi over 24, this vertical asymptote here is going to be at pi over 3, okay? Now I'm going to actually go in the negative direction. So I'm going to start counting backwards by 3. So I'm going to go 1, 2, 3, and that's going to give me, I'm going to do something there, and I can even write these down. So I'm going to subtract it. So I'll say a 5 pi over 24. Then I'm going to subtract another 3 pi over 24, so 2 pi over 24. Subtract another one, I'm going to get a negative pi over 24. Subtract another 3 pi over 24, and that's going to get me a negative 4 pi over 24. All right, so now from there, I'm going to go ahead, I'm going to mark these off. So I've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, now what I know is that on each end of these values that I've done, that's going to give me my asymptotes. I think it's a little easier to visualize with the asymptotes because I like to draw mine from the left to the right. So I'm thinking about there's no reflection and the cotangent graph should look like it's falling, okay? So from this key value here, I know I'm going to need to go up and my stretch is 5. 1, 2, 3, 4, 5. There we go. I'm going to get that point on there. This is my negative pi over 24. Then I'm going to cross, and then I'm going to go down. 1, 2, 3, 1, 2, 3, 4, 5. Kind of hear me counting. Okay, now this one is really stretched out, so it might be kind of hard for you to sketch this in. So I like to do it in little bits like this because we want this to come up and look like it's actually approaching those asymptotes, and then we're going to come down and approach the asymptote there. Okay, so that's a whole period. Now, maybe your teacher would want you to get 2 periods on there, in which case you could continue this here and get a little more partial period. You could get a point out here and kind of come down a little bit if you wanted there. That would be up to you and what your teacher's requirements, but this is generally enough to get an idea of the graph. I am going to go ahead and I'm going to fill in this negative pi over 6. That's from over here, negative pi over 6. And I can go ahead and I can fill in my pi over 12 and my 5 pi over 24, because I was going backwards, sorry, my 5 pi over 24, there we go. Okay, now let's go ahead and also fill in our domain. So x such that x is not equal to, we're going to grab an asymptote. It doesn't matter which one, this one or this one. Makes no difference. I'm going to choose the pi over 3. We'll write ourselves a reminder that this is going to be an asymptote. We're going to add to that the distance between them. That's going to be our period. So our period was pi over 2. Give yourself your reminder, your period, and then we're going to put a K so that we can generate all of our future ones. And just like tangent, the range of all cotangent functions is negative infinity to positive infinity. All right, so think through these, maybe jot down some extra notes for yourself on where you might have some questions, but these are the main steps in graphing a cotangent function.